Are you the gentleman from WA?
Yes.
Oh, okay. I'll forward them to you.
Hello, stop
Thank you.
chatting. If
Yeah, you are welcome.
you are not talking to me, don't talk to yourselves. Okay.
You are welcome, sir.
So we have an equation, and in the equation, there's a relationship. Every equation is a relationship, and in this relationship, I expect the student to understand the relationship. Are you okay? It's not really about working an example at all. It's really about understanding the equation. And once you understand the equation, there's no value that you'll be given that you'll be able to find. Okay, in other words, if I'm able to find A, B, and C, then I'll given any X naught, Y naught, which is the known coordinate, I'll be able to find the unknown coordinate. Okay. So I want to transform a set of coordinates from X naught, Y naught to Xn, Yn. That is the story of coordinate transformation. So you're given a set of coordinate X naught, Y naught, and you want to change them to Xn, Yn. This is coordinate transformation. It's all right. Now, I recognize that we're supposed to talk about global and local coordinate system. I want you to understand one thing, that for global coordinate systems, you're talking about like geographic coordinate system, longitude, latitude, yeah? Let's just call that global. Local coordinate systems, local are going to be rectangular coordinate systems, but I'll give you material if there's a need for that. Sometimes the syllabus that those who create the curricula may not even understand the needs of the particular program. It's okay because it may be more deeper than you think when you go into geographic coordinates, longitude and latitude. Okay, but we need to recognize that there is the global coordinate systems. It sounds more like geographic coordinate systems and then local coordinate systems. But these are some kind of rectangular coordinates, Cartesian coordinate system that we are dealing with. They exist, okay, on a certain axis, okay, horizontal plane, in which you have the x-axis and the y-axis looking like that. We can have the shifts and rotations, like I said. You could have a situation like this on a local coordinate system, or you can call it y prime, x prime, okay. And then you want to find out what are these coordinates in the new coordinate system of interest. This is what coordinate systems are about. Okay. All right. So in that expression, we stay with that expression. Then ax naught plus by naught plus c equal to xn. Okay. There's more to it than we think. Obviously, what is A? What is B? And then what is C? Okay. It's important to associate A and B and C so that the C and the D are shifts. So now I'll start with that. So C and D, these are shifts. Okay, but then A and B are actually trigonometric expressions. Are you okay? So if I go back, I take you back to my slide, okay, which I'm going to take you to right now. What is it? Okay, great. When you look at this, you can see that A is actually S cos alpha. Okay, if you appreciate your vector, yeah, if you actually expand the S into cos alpha sin alpha, so you'll be getting S cos alpha x naught, for example, S cos alpha x naught. So going back to here, S cos alpha then is A. Okay, so these are trigonometric expressions. S is the scale. Is that all right? So we factor scale into it. We've got the shift, and alpha is the rotation from. So what you want to do is that you want to actually shift first. And when you shift and you get there, then you rotate it. Okay, so shift, translate. Shift is the same as translate. Rotate is all right. Scale, if necessary, is all right. So that is basically the similarity transformation from one coordinate to the other. It's just a matrices thing. You need to. So that's why I'm saying that try and get your Texas Instrument calculator, because how do you then do an example like this? Here, dx naught is the same as c, and dy naught is the same as d. So c is dx naught, d is dy naught. Is all right. So there we go. Dy naught, dx naught, dy naught. That is c and d. Look at it carefully. That's what they are. If this is x not y not, obviously you understand that it follows like that. Okay, so what you do is I simply work an example. So we literally end the class by looking at the example that's in the book. I'm not going to even doing it from here. So it's going to be, so this is an expanded version of the equation. So this is like ax naught plus by naught plus c. See that? That's what we are looking at on top here. The first line. Of course, the second line is similar to it, just that this is negative bx naught, okay, plus a, yeah, ay naught plus d. Okay. All right, so let me just go here just to buy time. Can you imagine that? No, I don't think anybody is on my neck, but sometimes we need to just let you have a feel. So we have xn equal to ax naught plus by naught plus c. Okay. So yn equal to minus bx naught plus ay naught plus d. So c and d are actually shifts. Okay. Oh, it's even there. Well, I'm not even looking at it. It's even there on the board. All right, so you can see it's in the that we can actually write a matrix. Okay, get your Texas Instruments ready. Anyway, you can hardly hear what I'm even saying. So we can rewrite this whole expression in terms of matrices. Xn, Yn equal to x naught, y naught, 1, 0. So in matrices, we multiply the row by the column. Are you okay? Remember that vector multiplication 0, 1. So we want to multiply that by, so what are we going to multiply by? So to get our a back, you get a. To get our y naught back, you need b. To get our c back, we need 1. We need c, of course. To get d, of course, is 0. So put d here. I mean, like, this will help us to regenerate the equation on top. Is that okay? So this is getting us somewhere. The only challenge with this is that we can't find the inverse of this matrix here. we can't find the inverse of it. Okay, we can't, and that's a challenge. But the interesting thing is that we can write more equations. For example, hold on, I think the shouting is getting too much. These kids sometimes finish up very well with this. Try to get this one and then we just say goodbye. We can all go home. So we to solve for the coefficient. Remember that I said we need to solve for the coefficients, isn't it? So we need to find the inverse of this one. So let me just put it this way. If you had x and d, if you had x prime equal to v times a, and we need to find, so a is a coefficient. So, okay. So undo, or let's call it c, coefficient. We need to find a coefficient c, then it's important for us to do c equal to x times v inverse. So this can be done in matrices. You've done that already in the math class, is that also? We can't find the inverse. Okay, so but we can find the inverse of a square matrix. Do you get it? So you write more equations. So in other words, you take more controls. So you can have, remember that the whole equation we have up there is being written using just one control with x naught, y naught. So we can pick another point. Then we have 4 equations. When we have 4 equations, we have 4 unknowns, a, b, c, d. We can find a, b, c, d. So the more points we have, the better. Are you okay? But if we go beyond the number of unknowns, okay, then in that case, we can use what we call the least squares to solve for it. Is that okay? All right, guys. I'm not going to bore you, but obviously, we can just put in values. Typical example. Let's go back to. Hey, someone says something. Said, please, the internet is helping. It's not helping at all. You keep breaking. Okay. But I think I warned the other class that I'm teaching that everyone should check their internet. So the same warning goes with you. Online means that you don't have to get good internet. But anyway, even I'm breaking. I'm using Vodafone. I'm still breaking. All right. So this is it. We have to find the more equations to write here. Okay. All right. So yeah. This is an example. We want to actually transform this set of equations. We have this information, 2 points. We can write, put in values, solve for the inverse of a square matrix. And then we are going to be just fine. So here you can see we're just solving for A, B, C, I, C, Y. In fact, in this particular note, you see that the shift has been represented by dx, not it's been represented by c, it's been represented by cx. They all represent the shift along the x-axis. Please, sorry for the inconvenience, but it happens. Yeah, writing these in Word takes time. So when you see some system material, sorry about that. In fact, this is no excuse. I'm being lazy. Yes, I said that. So having obtained A, B, C, and X, we can now put it back and then start solving. So here you can see that we've actually solved for this points, you see. So this is that, and then we know this is A, this is B, okay, this is D, this is C. Again, that if you expand it, you get your A, B, you get your AX naught, BY naught plus C, XN, and you have a transformation. we have a transformation. So that's the answer right there. Okay. So that is coordinate transformation. This is just introduction. I think I can't talk too much about it. There's a lot in this course, and if I'm not careful, you'll be overloaded and you wouldn't even know where you're trying to end up at. This is to introduce you to it. The other transformation, you know, you can read about, but this is the one I think. Should I even ask you a question on this? I don't even know. We'll find out. We have the affine transformation. So the affine transformation is a bit different. In that case, this, instead of you having like alpha, you have alpha plus epsilon. Okay, so as you can see, we apply alpha plus epsilon at one side on the y-axis, and then the x-axis we are applying alpha. So that's the slight difference between the two. But then again, you end up with the parameters expressed in the trigonometric function. And then there you go, A, B, C, D, E, F. Now you have 6 unknowns. So how many points do you need to solve for 6 unknowns? How many points? If anybody can hear me, they can say it, but I'll wait for 2 seconds. If I don't get any answer, I'll tell you what it is. But it's always interesting to ask the class a question and then hear them answer for it. So you need how many points to solve for 6 unknowns using a set of equations that you write, 2 sets of equations for 1 point. So you need 3 points. Are you okay? Any more, use this least squares. You can actually have what we call the polynomial projective transformation. Okay, here too we have unknowns. To solve them the same way, literally. So that is it for coordinate transformation. That's all I needed to know. Pay attention to the conformal similarity transformation, and you'll be fine. If you have a question, leave it in the comment section. Okay, subscribe so that you can have any more videos that will be posted on this channel. Okay, so thank you very much, and